MATLAB school. In this video, we are going to simulate the simulation of fuel cell hybrid vehicle, uh, that is Toyota Mirai. So this is the MATLAB simulation. So let us get into the simulation. So this is the model we are going to simulate. So here we have a battery, and this is inverter, and here we have the PMSM model. So inside this PMSM model, we need to give certain parameters like the nature of the back EMF, here we need to select the type of back EMF. If it is trapezoidal, then it becomes BLDC motor, and if it is sinusoidal, then it becomes permanent magnet synchronous machine. So here we are going to integrate two things together as per the technical specification of Mirai. So if we can go through the technical specification, there will be one fuel cell coupled with a battery. So the battery will have a capacity of 4Ah, and here the number of cells is 330. Fuel cell stack is 330, and these are the other specifications of uh, Toyota Mirai. So based on this, we are going to simulate the model. So here we have the battery, and inside this we have the fuel cell. So in fuel cell, uh, we have we need to give the number of cells, then we need to give the voltage as well as the current ratings. So after giving that, we need to plot the VA characteristics. So here we have the voltage versus current waveform. As you can see, at this point the current is 10 and the voltage is 270. At open circuit, that is without any load, the voltage would be 300 volts. And here we have the current of 570 amps, and the voltage drops to 200. So at this point, the power would be 2.7 kilowatt, and when maximum current is drawn from the fuel cell, the power supplied by the fuel cell would be 114 kilowatt. So basically what we are doing here is we are trying to charge the battery from the fuel cell through a boost converter. So here we have a boost converter. This boost converter will be given with a pulse coming from CCCV charging technique. So constant current and constant voltage charging. So the current reference current given for constant current charging is 20 amps. So here we have the reference current, and other side we have the actual current. Then the difference is given to PI controller. Then we have a PWM generator. So 30,000 hertz is the frequency that we give uh, to the PWM generator. So it will be producing pulses at that frequency. So initially the charging will be based on constant current charging, and later it will be changed to constant voltage charging. So as soon as the SOC of the battery crosses 90%, the mode of charging will get converted to constant voltage charging. So in constant voltage charging, we have a few things like the sample and hold circuit, also the comparator. So this sample and hold circuit will be taking the voltage which is available across the terminals of the battery at the end of constant current mode charging. So that becomes the reference current, reference voltage, and with that the actual voltage will be compared then the error will be given as input to the PI controller, and further that will be varying the pulse width of the pulses given to the boost converter. Then we are cutting off the fuel cell supply as soon as the current crosses 400 amps. So when 400 amps is crossed, we will cut off the battery from getting charged from the fuel cell. So um, so here we have the battery, IGBT connected to the battery. So this will get cut off as soon as the SOC of the battery crosses 95%. So this happens for the reason that when the if the battery is fully charged, it cannot uh, it cannot take or accumulate any more power from the regenerative braking side. So when we apply the brakes, the regenerative braking will be applied. So during that time, there must be some provision left with the capacity left with the battery to take energy from the wheels. So to accommodate that, we are stopping the charging as soon as the uh, battery reaches 95% of SOC. So when the current crosses 400 amps, uh, the net current will be supplied from the battery and not from the fuel cell. So when the batteries, when the current drawn from the supply is less than 400 amps, at that time the fuel cell will be used to charge the battery as well as the uh, as well as to run the motor. So here uh, I have given two provisions. Either we can run the battery at regenerative braking mode, or we can run the uh, vehicle uh, in frictional braking mode. So if it is run using regenerative braking mode, uh, the range will get extended, and if it is run using frictional braking mode, there will be the range will get decreased to a certain extent. So here we have the FOC model. So this is the longitudinal driver model. To this model, we will be giving reference speed as well as the feedback speed. And from here, we are taking two things. One is the acceleration command, and the other one is the deceleration command. So deceleration command corresponds to the braking of the vehicle, and the acceleration value will be in between 0 and 1. Also the deceleration command will be from 0 to 1, so it has to be manipulated to the corresponding values. So what we are doing here is this: the values of acceleration command which lies in between 0 and 1 will be converted to some value for producing IQ reference. So as you know, in the case of motor control of, BLDC motor control, we will be giving IQ reference from the previous stage, and the ID reference will be 0. So with this ID value and IQ reference values, we are comparing the actual values of ID and IQ. So that we are getting it from IBC value after going for clocks and procs transformation. So we are going for ABC to alpha beta transformation, then alpha beta will be converted to DQ. And so here we have again the inverse Parkes transformation. So here we are going with DQ to alpha beta transformation, and so the alpha beta will be used to produce pulses for the 6 switches in the inverter. So here we are going for SVPWM generation. The drive cycle that we are using here is the Indian drive cycle. So that we have so here we have the IDC. So if you double click this, I mean, if you double click this, it will come here, so that this comes as a variable, and we can retrieve it back as the uh, drive cycle variable. And here we have the transmission. So uh, the transmission, we have a gear, and these are the inertia sources. Here we have the vehicle model. So to this vehicle model, we have connected four